Yes.
Yeah. So, assignment number 4, question number 6.
I will share my screen.
Yeah, sure.
Assignment number?
4.
Okay.
Sixth question.
Okay. Write a parametric formulation with 3 interpolation functions. The minimum number of quadrature points is to ensure accurate integral solution should be 3. Okay. Three interpolation functions, it means the order of the approximation is like second order approximation, right?
Yeah.
Okay. And second order approximation. And you,
So R is
yeah. Sorry, I forgot the formula. It is R.
P plus 1 by 2. R is equals to P plus 1 by 2.
Yeah. Okay. P will be the order of integral, right?
Yeah.
So your K would be something in the something in this way. So this would be your first order. This will be your first order. So second order polynomial. Okay. So if R is second, it would be like 2 plus 1, 3 by 2 plus half, right? Okay.
So 2, that is what I gave the answer, but it was given, it is given wrongly.
Okay. Interpolation functions.
Like in above questions, in other questions,
Yeah.
also here, like it was asked the same questions, but their answer was like yeah, here it like
Okay.
it is calculated by the same formula.
Okay,
Okay,
maybe
maybe
here
here
they are
they are
looking
looking
at
at
mass
mass
matrix.
matrix.
If it
If it
is
is
A
A
is
is
this
this
sign,
sign,
let's
let's
say
say
if
if
it
it
is
is
mass
mass
matrix,
matrix,
then
then
it
it
would
would
be
be
n
n
transpose
transpose
and
and
D gets,
dgets.
then
Then
it
it
would be
would be
like
like
second
second
and
and
second,
second.
it would
It
be
would be
like
like
fourth
fourth
order
order
polynomial,
polynomial.
then
Then
B
B
would
would
be
be
like
like
5
5
by
by
2
2
plus
plus
half,
half
3.
3.
But here it is not like such like simply it simply degree is to
Sorry?
Sorry?
like here interpolation function is given as there are three interpolation functions.
Yeah,
Yes,
3
three
interpolation
interpolation
functions
functions
means
means
2
to
second
second
order
order
polynomial.
polynomial.
Yeah, so nothing else is given.
Yeah,
Yeah,
nothing
nothing
else
else
is
is
given
given
actually.
So just 3 plus 1 matrix multiplied by 2.
Actually,
Actually,
they
they
should
should
give
give
which
which
integral.
integral.
I
I
don't
don't
think the
think the
question
question
is
is
proper,
proper,
to be
to be
frank.
frank.
They
They
should
should
mention
mention
which
which
integral.
integral.
Yeah,
Yeah.
Yeah, even if you write this, you have written the term for stiffness, but
yeah,
what
Yeah.
I assume that the total degree comes out to be 3, like fourth order degree. So that's why it is written. Sorry, this is third order. Second order polynomial. Total, like if I have three options to take in consideration, I have second order as I told you.
yes,
That's
Yes.
it. Why?
yes,
Yes.
Yeah. Don't I don't even have to write here Lagrange multiplier. Like maybe the equation which is there finally is the first order,
yeah,
Yeah.
like
yeah,
second order polynomial. Okay.
yeah.
So
Yeah.
R is equals to p plus 1 by 2. This is simple. I am just disappointed.
Okay,
Okay.
like
Like
I'm
I'm
not
not
sure
sure
about
about
this
this
question. I
question. I
don't
don't
think
think
this
this
question
question
is
is
uh,
uh,
given
given
completely.
completely.
Just by
Just by
this, I
this, I
don't
don't
think we
think we
can
can
say
say
how
how
many
many
points are
points are
required.
required.
Yeah, and that's
In the
In the
other
other
questions, if
questions,
you
if you
saw, they
saw, they
gave
gave
the
the
integral
integral
k,
k,
and
and
then they
then they
said
said
integral
integral
m.
m. Hmm.
Yeah,
Yeah.
probably if
Probably
you
if you
want, you
want, you
can
can
mail
mail
if
if
you
you
get
get
some
some
kind of
kind of
contact
contact
whom you
whom you
can
can
contact. You
contact.
can
You can
ask
ask
them
them
about
about
this
this
question.
question.
no, there is no such contact. That is what I am asking you. Like if you have, you can have it. Okay, like you can say,
No,
No,
I
I
don't
don't
have
have
any
any
contact
contact
actually.
actually.
that's
Who
Who
like I
like I
don't
don't
even know
even know
who
who
creates
creates
these
these
assignments
assignments
and
and
rates
rates
them.
them.
okay.
Yeah.
Yeah.
Okay, fine.
Yep.
Yeah.
And one thing, like in general, like
Yes.
Yes.
uh, before, like you also told me that in the triangular nodes, you were telling that it need to be equilateral triangle to be equally distributed, right?
Oh,
Oh,
that
that
one.
one.
Yeah.
Yeah.
Actually, I
Actually, I
didn't
didn't
look
look
into
into
that.
that.
But
But
I
I
heard
heard
that
that
for
for
at
at
least for
least for
linear
linear
approximation,
approximation,
that
that
would
would
be
be
the
the
case.
case.
Like if it's linear approximation, that would be the case I had.
Okay, so if it is quadratic and let's say we have 6 nodes, then it is equally divided on 16.
I'm not sure actually. I need to see. Actually, I forgot to look into that. It's like something like this is the force, and you are using three
And the question
nodal
let me look
element.
into it.
Yeah, this one, right? Something like this.
Yeah, triangular element.
Yeah, it's at least one version of that. Something like
This
this.
load is distributed. Yeah, now at nodes we have equally distributed, like equal
Yes.
loads,
Yes.
and that will be 1/3 of total load or total flux.
Yes. Yeah.
So in this like 25 minutes.
And that equals,
Yeah, here,
using this relation,
when we have this
E1,
transformation equation,
what is the value of S?
that the relation between
Sorry.
x, y.
Can you tell me the context to what's happening here?
Okay, so here it is a triangular element.
Okay.
And for that we are calculating the boundary integrals. And for boundary integral we need to calculate approximately xi1, xi2, xi3. These things will be calculated.
Okay.
But before solving, so like our local coordinate system is introduced, ST. Yeah, this ST local coordinate system is introduced.
Okay.
Because we need to find across side 1. So it is taken parallel to the side. Now the doubt is like this, like it is told that the relation between these coordinate systems is linear. That's why we use this equation x is equals to a1 plus b1 and a2 plus b. And then later on, depending upon the coordinates of nodes, this a value of a1, b1, c1 and a2, b2, c2 has been found out. So the doubt is like how we come up to this conclusion that the relation between the two coordinate system is linear.
It's first thing the local coordinate system which we are taking is just a straight line, right? And can you say what are this SNT?
SNT are the new coordinate system. Like instead of x and y, we have taken s and t.
Okay. This is SNT. And instead of x and y, they are taking SNT. Okay.
SNT is local coordinate system.
Yeah.
And so we need a conversion formula for that. For it, we have written this transformation formula like x is equals to this a1 plus b. So
Yeah.
and this formula is written because it is told that the relation between these two coordinate systems is linear.
Yeah.
And the doubt is like this: how we come up to this conclusion that the relation between these two systems is linear.
Whatever we are dealing with here, we are dealing with a triangle. So we just individually we just are dealing with lines. Okay. So and we want to arrange the coordinate system according to those lines. It's something like there is a triangle. And here they were saying that this is the original coordinate system X and Y, right? And this is another coordinate system S and T. Is it?
Yeah.
So they're always taking this. These are always lines, right? Triangular or rectangle. So always those coordinate system will be along this. One axis is along this. That's what they have taken, something like that. So this will always be a linear transformation because of this. It's like from origin you are shifting it from here to here, and then it's just you are rotating or stretching. That's it. Let's say you have some other shape like this. Okay. And you want to have your coordinate axis as this S and this T. This won't be linear.
Okay.
So
The doubt came because in geometric transformation, we have this line. One line is transferred to the other system, and we say that it is quadratic. We are transferring from linear to quadratic.
sorry, from linear to quadratic.
Yeah, in geometric transformation,
Okay.
like when what we do, there we sometimes say that we usually say that we are transferring from linear to quadratic element, something. But there, that geometric shape is a straight line only.
Yeah, geometric shape is straight line only. Like if even if you take quadratic, it would be element would be like this.
Hello.
Yeah. This is like 2D. Yeah. Am I?
I'm not able to hear you. Yeah, now. Okay, yeah, what you said. Actually, voice
Yeah,
got
like
lost.
in 2D quadratic element, it is still be a square with lines. Just the number of nodes increases.
Yeah, but the equation which is defining such lines are quadratic.
You mean the things which represent this?
Yeah, it is a linear line. Like
Yeah.
equation is linear, like ax plus b, like this. Like what would be
Yeah.
the equation of line?
Yeah, these are straight lines
Like
only.
we have this equation. Yeah, but we generally have this equation as a plus bx plus cy and
Yes.
dxy, something like this, plus dxy.
Okay.
So this will be the equation of complete domain, not individual line, obviously. But actually, I also forget the geometric transformation. Yeah, here it is. But it was told that transcription from VA to minimize the discretization error. Okay, when I get there, right now, like because just because they are both lines and we are doing only
Yes.
transformation and rotation, so we can
Yeah,
say it
that's
is linear transformation.
yes.
Okay.
Yes.
Okay.
Yeah. It's like whatever transformation we take, we want to take linearly. Generally, at least in engineering, we never go to non-linear transformations. We always stick on to linear transformations. Any other doubts? Yeah. Is it fine? Like, shall I start solve some problem?
Yeah, sure.
As I was saying last class, I'll just show you some 2D problem, and we'll see how it goes. It's the same problem which we were solving initially, but just we'll solve it in 2D sense today. First, this is heat transfer problem because I want to solve some single variable 2D. Then we can go for second variable. So let's say this is the problem. Say this is the coordinate system. So this is heat transfer problem, conduction. It would be like the governing equation is like this. Okay. And boundary conditions are at y is equals to 0, temperature is 0, and at y is equals to 2, there is some heat flux Q is equals to 1. Okay. So this is the problem statement. We will solve it using FEA, and just for case of simplicity, we'll just stick on to one element. One element linear element. So we'll need to find the weak form first. For that, we'll just multiply with sum 8 times delta K delta T. D is equals to, there is no internal force, so it will be like internal heat source, so right hand side will be 0. It's 0.
Write this dv.
Yeah, that's what I was thinking. Maybe we should write it as instead of volume to write it as area. Let's do the problem. Yeah. Let's stick with area. Okay, upon using UV rule, we can transform it as this. This one, let's call whole area omega. This is like, and the boundary it as gamma. So this one runs over the boundary, this one runs over the whole area. Okay. Then we will get TS W, we can take it as NI and T as NJ, TJ.
Excuse me. Instead of n, can you use xi? Would be comfortable.
Okay. Psi. This one, right?
Yeah.
Okay.
Yeah.
Fine. This would look like minus del psi I k del psi j dj dA minus psi I k delta t dot n dl. This one I am keeping it as it is because actually Q is minus delta T, right? Heat flux.
What can you please repeat this part?
Heat flux. This is the
this k delta t dot n is what?
no, I'm just keeping it as it is. I'm not using any substitute on this because these are directly secondary boundary conditions. Like heat flux Q is minus K delta T. So this one would be nothing but Q dot N. This term.
Minus Q.
Minus Q dot N. Okay. And that one is like these two sides Q dot N is 0. This one Q dot N is Q naught. I think
what this Q dot N is 0 at these two points. because n q is 0. That's why.
Yeah, Q is 0.
And at the bottom.
At the bottom, temperature is 0. We don't know about the heat flux. Okay.
Now, how we it must be given that these two there is no heat in these two edges, and in the bottom there would be a heat transfer.
Generally, if they don't mention anything on the boundaries, it's assumed that it is like a free flux condition, like that is there is no heat flux. So it's like ideally you need to do boundary condition on all the boundaries. It's like either if it's temperature they will mention, and if there is some non-zero value of heat flux they will mention, and if they don't mention anything it's like kind of zero heat flux condition. It's like you are not specifically maintaining any temperature on that, and you are not giving any heat flux to that. So at this places Q will be 0. So this one you can keep it outside as these are constants. Then it would be like delta psi I, okay, delta psi j, dA, dj minus, okay, is equals to, this one I am taking on the other side. So this is your format as in like Kij Dj is equals to Fj. Actually this dot here. Okay. So let's look at one term K11. Okay. And these are all in XY coordinate system. Right. We want to transform this one into standard element. Okay.
Okay, here just a minute. This is the transformation I'm talking. Like sometimes we go from linear to quadratic or quadratic to linear. So, but there the like it is line only. But we say that we are moving from linear to quadratic.
It is line only, but we may take quadratic approximation to that line. You are saying when we take x is equal to ni hi, we may use quadratic shape functions for this, right?
Yeah.
Yeah, we may use that, but true. between that.
I have actually this doubt from one example actually, like
Yeah.
in thermometer. Like if
Okay.
we have a thermometer which are using two different kind of liquids, then
Okay.
their coefficient of expansion and those things, one could be a linear expansion and another it could be a quadratic,
Yes. Yes.
right?
Yeah.
Yeah, so we can't. Yeah, so when like such kind of thing is also like happening, that they maybe have linear lines,
Yeah.
but the individually it could be quadratic.
True. Makes sense maybe. Uh,
Yeah.
hmm. Maybe even I need to
And
look at.
because we are using,
Yeah.
yeah, like even because we are using there in triangular element, we are using linear triangular element. That does not help, because we can have quadratic, linear, or any element. It's the relation between
Yes.
quadratic systems, not about individual elements. So that is a different thing. We can have a linear and quadratic element with the relation. Even if the relation is linear, we can have a
Yeah.
quadratic triangular element.
Uh, okay. Between this, you're saying we can use linear transformation, but
For the
the
same
triangle
transformation,
maybe. Yeah. The
quadratic.
inside. Yeah. Yeah. Still yes.
Yeah, that is why. So it doesn't help that it is a linear triangular element. So how we come up to this conclusion that relation is like between quadratic systems for coordinate systems.
I think maybe by default, I think we need to look at as a triangle only. But just when we are going for integration, maybe we are just approximating them using these approximations. That would be helpful, right? If you look at it in that way.
Maybe you look into it and then we can see.
Yeah, I will also come back on that. Okay. Okay, this is the transformation which we want to do. So we have these are like, let's say in terms of h, and let's take n as a function of psi and beta. So we will have dou in by dou psi dot product we will have 1 by j square times j t psi d eta. This 1 by j comes because of this delta x derivative with respect to x and with respect to eta.
Okay, actually this part is not still discussed.
Okay. I think he didn't show any example
Yeah,
problems.
No, it is in 7th and 8th week, like in the last.
Which week is it running? I think 7th week is done, right?
Yeah, but I am actually a week before. But even it is not in 7th week; it is in 8th week.
No. Okay. Maybe it's fine.
Maybe we can
proceed. We can proceed. No problem.
But I don't get like how you write these situations, like in matrix, like how.
Yeah, delta xi means dou xi by dou x, dou xi by dou y. This is the gradient, right?
It is in matrix.
Yeah, matrix. We write it in matrix form because that's easier to use. We can always write it like this as well, no problem. This is both are equivalent. We use matrices. It's easy to handle. That's it.
Okay. Yeah, we get k is taken out because it is constant, right?
Yeah, k is constant in this. Okay. So this will be your K11. So if you want to evaluate this integral K11, so you have this expression. You can take the value of this expression at 4 gross points and then evaluate the integral like this. Four gross points are like plus or minus 1 by root 3. Shall I show what those are, or you can calculate, I guess, right? This one K11.
Yeah.
You have N1 expression as xi and eta. You can find its derivatives. You can find the Jacobian. You can find for all the gross points, like gross points, and then you can find K11, like summation over gross points, this expression. Into weight, gross weight. In this manner, you can find out the stiffness matrix of one element. This is like one element of K11. Similarly, you can do it for all K11, all Ks. Fine, right? You can practice this. I want to go into F and I want to show you how it will be. for I is equal to 1, like F1, it would be like psi 1 q dot n dl over whole domain gamma. Let's say this is 4 sides. Okay. 4 nodes. So we can divide this into 4 parts, like S1, like this integral, S2, okay. We know that when we are taking psi 1, so it is 1 on this and 0 on all these things. So it's 0 on psi 1 is 0 on this both sides, right?
Yeah.
So S2 and S3 we can completely 0 because psi is 0. And on S4 Q is equal to no, like if psi is 0, then whole integral will be 0, right? I'm saying this whole integral. S4 Q dot n.
Psi 2 and 3.
Yeah. No, I'm saying I'm calculating for F1. This is only F1, not all F2, F3, F4. If I go for F2, then it will be again another.
Oh, what is this we mean by M1? Sorry.
Yeah, when you have this format, so right hand side will be a like column matrix with F1, F2, F3, F4.
Yeah, so F1 is
It's like it's equivalent to flux on node 1.
the flux on node 1.
Yeah.
So why Xi1 and Xi1 are 0?
Xi1 is 0 on S3 and S2. The shape functions it will be 1 on 1 and other 3 it will be 0, right?
But that was at node point, not. But here we are integrating on whole.
Yeah. Yeah. S2 is this side 2. If shape functions not on just this, linear shape functions they are 0 along all these lines. If you remember psi 1, okay, at least on standard, psi 1 was something like, if this is your first node, it was like 1 by 4, 1 minus psi into 1 minus eta. Right? So along this line, which is psi is equal to plus 1, psi 1 will be 0.
This is not covered, so okay. I will.
Yeah. Okay, 2D shape functions is not covered.
No, that's what I'm saying. It was in maybe in last week.
Okay, okay. I think, but I already covered in one of the tutorials.
Yeah, that they are two questions and assignment, but they are not taught.
Okay, okay. It's fine. And here's okay, these three are from on S1, Psi1, Q dot N, DL. This is your F1. And similarly, let's say if you are taking F3, let's see F3 how it would look like. This would be 3. And Q dot N on S2 and S4 are 0. This Q dot N is 0. This Q dot N is 0. 2 and 4. And this is side 3. So on S1, side 3 is 0. So this is 0 here. So for F3, you will just end up with side 3, Q dot N, DL. And Q dot N is nothing but Q naught, which you have on top. So it would be like side 3, okay.
So what is F1? Then now we in F1 we can substitute this Q dot N equals to.
We don't know what is Q dot N on S1, right? So this is an unknown which we need to find out actually. On S1 we know that temperature is 0, but we don't know what is Q. Okay. I think for this we need to find what side 3 will be. Once we know side 3, then we can calculate this integral.
Yeah, it's okay.
It would be something like this one is linear, right? At this point it is 1, side 3, and it is 0 over this. and it is like 0.5. It would be something like something like this. It would be psi 3, not psi 3, but at least on this line y is constant. Although I'm directly writing in terms of x, actually you can convert this into xi eta and then still do it. It's still fine. This one to 0. Two times 1/4 times 1/2 times Q0 is equal to Q0 by 2. So you got it right, how it will be Q0 by 2 here. Like this is the background calculation just now I remember. So like sir was saying, right, if this is Q0, we will get directly as Q0 by 2 here and Q0 by 2 here.
Yeah.
So this is how you will get it.
Yeah, we get it, but like for every element, like this is general, like we distribute equally on all the nodes.
Yes. Not all the nodes. Here it is only on this side, right? So this will be distributed only on these two nodes.
And there is one thing also, like it is because it is uniformly distributed. If it is not uniformly distributed, then
then it won't be equally distribution. Then you need to find out this way. It works only if it is uniformly distributed.
yeah. So it happens to be that it got equally distributed.
If it is, So basically, like you have this expression like for force, you need to substitute in this and then find out. You are getting Q0 by 2 on F3. Similarly, F4 also you will get
Shape
Q0.
doesn't matter.
No, shape doesn't matter.
Yeah, that's why in triangle, like it is not necessary that it is equal to any triangle. If we have some equally distributed load, then it is equally shared by all the nodes.
Yeah.
But exact reasoning is still like not can't say like what I can how can we explain that why it is equal, like if it is a triangle on three the nodes, because we have assumed linear element. If we have assumed quadratic, then it also it would be equal, like
quadratic elements, then actually you'll have 6 nodes when you take quadratic triangle element, right? 3 on sides and 3 on this. So on this and this they won't be same. You have to find out actually.
Because it is linear element and it is
Yeah, I think just because it is linear, it is coming out to be both this is uniformly distributed and these are linear elements. That's why it is coming out to be equally distributed.
okay.
Yeah. So right now, if you do it, then you will got to know that F1 we don't know. We need to find out, and F2 also we don't know. F3 we just saw that it's Q naught by 2. F4 is Q naught by 2. You can find K, all the things K1, K1, K2, so on. And then there is T1, T2, T3, T4. Okay. So this is where you apply boundary conditions. These are unknowns actually. Still. Okay. And then there's another boundary condition which is T is equals to 0 at bottom, which is 1 and 2. So here T is 0.
T3, T4 is also unknown.
T3, T4 are unknowns. So these two are unknowns and these two are unknowns. So you have to find these 4. So this is how you solve 2D single variable problems.
Please check in the next class like that geometric transformation.
Okay, yeah. Geometric transfer.
One like this thing. Yeah, and this thing is clear now that how this load is equally getting distributed. So that is okay.
Yeah.
Only this geometric transformation and one more
Okay.
thing if you like if you explain in next class is about shear locking.
Shear load.
Yeah.
Like something like if there is this and you have this force. Is it?
Like I have read this concept in one MGM this first part.
Okay.
You would like to just explain the concept like how I will use like in the next class like
Shear load.
transformation and this shear locking.
Oh, shear locking. Okay. Yeah, that's okay. I get it. Okay. Yeah, maybe next class I can do shear locking, geometric transformation, and then maybe 2D 2D degrees of freedom, like elasticity problem.
Yeah. Like it is like vector. You said it is a vector. We take vector equation or something.
Yes. Sorry.
You said we take a vector equation to solve like vector. Is it a vector?
Yes, del dot sigma is 0, right? So this will have 3 equations.
Yes. So this equation, what we are taking right now, that is not a vector because
This one is scalar equation which we took it now. This one is just a scalar.
But it has a variant in like how we are deciding this thing, because T is a scalar, that's okay, but how equation is a scalar?
T is scalar,
And
right?
we have a vector.
Okay. Delta T is a vector. It's gradient of T.
Yeah.
Right? And we have del dot product of delta T. So this vector with vector dot product, so it becomes a scalar.
Okay. And for vector equation we get finally a vector.
Yeah, this one is second order tensor. So after dot product we'll get a vector. Okay. Next class maybe I'll tell you how we deal with it. Although it's like this, we still convert the equation into same as TU is equal to F format. Even though this is a vector, still we will try to make it in this TU is equal to F format only. I can show you that. Next week is the last week, is it?
Yeah.